Hello everyone, I am Monica Bhushan and today we are starting partial differential equation lecture number 6 by eliminating arbitrary function. Okay, where the question will be written in some special form. Okay, so the equation will be in the form of phi u comma v equals 0. Okay, so first we will be discussing that what does it mean, right? What is phi, what is u, what is v, right? So if we have seen the previous classes, so in formation of partial differential equation by eliminating arbitrary functions, we had seen form 1 and form 2, right? No. So in form 1, what we had seen that we had only one function in our equation, right? One function in the equation. Form 2 was what? We had two functions in our equation, right? So in today's class, we are going to see form 3, and this form 3 is actually some special form. The form is what? Phi u comma v equals 0. Okay. So here the arbitrary function is this phi. Okay. So this phi is the arbitrary function, and u and v, these two are also functions, but these functions are the functions of xyz. Okay, so that means what we are saying, in your question paper they will not be giving you uv kind of thing, right? This our simplicity, we have just given the name uv. Basically this u and this v will be actually expression of, u and v will be expression of something x comma y comma z, anything will be there. Okay, so basically u v are the functions of x y z. Okay, but this phi is the arbitrary function, and this arbitrary function, this phi only, we have to eliminate from our partial differential equation. So in this given equation we are going to build partial differential equation, correct? No, and this partial differential equation can contain x, partial differential equation can contain y, because x, y will be our independent variables. Here also we will be dealing with two independent variables. They will be our x and y, and we can and z will also be allowed, correct? If z is coming in our equation, that is also okay. Z is the function of x comma y, fine. Even we are going to find first order partial differential equation, fine. So we are not going to find second order partial differential equation. So we might be getting p also. If p is coming, then it is also okay. We might be getting q. So q, if it is coming in our partial differential equation, that will also be okay. But we will not face any rst. Okay, rst will not be coming in this form 3. And the reason, because, and if you have seen the previous classes, then only you will understand that what we are talking here right now. So form 3 will not contain rst. The reason is, if we are talking about this form right now, so this is the form which we are going to work on. So here only one arbitrary function is present, correct? If I am having only one arbitrary function, that means I am going to find first order partial derivative only. So if I had, suppose, function f, I had function g, so in one equation only, so that was actually form number 2. Two functions were present, and because of that only we used to go for second order partial derivative, correct? No, first form was also my first order of partial derivative. That means only pq we wanted to know, and here also this will be my first order partial derivative only. I don't have to go for second order partial derivative. Okay, fine. Now we will be seeing the question, then it will be much more clearer that what I am saying here. Okay, so here is the question. So what we are finding out, we are going to form the partial differential equation. Okay, and the equation which is given to us is this one and this one. Okay, and my job is to build partial differential equation from this given equations, fine. So but we have to use the method by eliminating the arbitrary function. What is my arbitrary function in this first equation? So this phi is actually arbitrary function. Okay, So phi is arbitrary function, x is independent variable, fine no, y is also independent variable, and z is the function of x comma y. So z is nothing but fx comma y. So x, y, z all are okay. We have seen these in previous classes also. We don't have any problem with these elements in our PDE, but this phi will not be there. Okay, we have to work so that this phi will get eliminated. Okay, and what is this form? Even question number 1 and question number 2, if you will see, so this is actually our u. We are going to say this complete expression is nothing but my v. Okay, so this will be your u and this will be your v. So if this fashion I will see my question, so this is your u, this is your phi u comma v equals 0, right? So that means this is my form 3. And then if it is my form 3, so we are going to discuss that how we are going to solve this type of question. Okay, so and that was only I was saying that they will not give you u or v kind of thing in your exam. U is, I'm writing instead of x plus y plus z, I'm writing u, and instead of x square plus y square minus z square, I'm writing v. And similarly for your second question also. So in your second question, f is the arbitrary function. Okay, now we will be starting with the first question. Okay, so in my first question also, so in this method also we are going to follow same two steps. If you remember, the step number 1 was what? Step number 1 was, in our previous classes we had seen that we had to actually find the partial derivative with respect to x and partial derivative of this given equation, correct, no, with respect to y. So step number 1 is here. What my step number 1 is, I have to find partial derivative with respect to x of my left hand side also and my right hand side also, fine no. Okay, similarly I have to find the first step only. What I have to do, I have to find the partial derivative with respect to y. Okay, partial derivative with respect to y in my left hand side also, and partial derivative with respect to y in my right hand side also. Okay, so this is only step number 1 which we are going to follow in this form also. Okay, and the second step will be what? Whatever will be my new equations. Right now we will be getting two new equations, we will be getting, correct? So we just have to deal with these two new equations, what we are going to get after finding out this partial equation. Then we will be actually rearranging these two new equations. So we will be building PDE. Fine. So now we will be starting our step number 1. So here I am just writing down, instead of phi x plus y plus z x square plus y square plus z square equals 0, I am writing down phi u comma v equals 0, where u is x plus y plus z and v is x square plus y square minus z square only. So later on I will be actually substituting uv only. So so this I'm just giving name, suppose equation number 1, very first equation. So what I have to find? I have to find the partial derivative with respect to x. So okay, so if I have to find del by del x of phi uv, that means I have actually two functions u and v also present right now. So that means I have to find del by del x of phi with respect to u. Okay, because first is the function u, and then I have to find del by del x of phi with respect to v also, correct? No, here is my u and v also in my this arbitrary function. So I am finding out del by del x of phi with respect to u and del by del x of phi with respect to v. I think things are clear here. Okay, so this will be your left hand side, and right hand side is what I am going to find del by del x. Similarly, I will be finding out del by del y of phi with respect to u, fine no, plus I am going to find del by del y of phi with respect to v, and that will be my left hand side, and the right hand side will be your del by del y of 0, fine. Okay, so now what I am going to write, so I am writing down del by del x of phi with respect to u, okay, plus del by del x of phi with respect to v, fine no. Okay, and then right hand side is what? Del by del x of u, del by del x of 0, that is nothing but 0, because del by del x of constant will give you 0. Okay, similarly, if I am going to find del by del y of phi, then what I have to write down here? I'm just writing down here y, and then y. Okay, so this will be what? So this is nothing but I am finding out del by del y of phi with respect to u, phi no, plus del by del y of phi with respect to v. Okay, and this is my left hand side, and right hand side is what? Del by del y of 0 will give you 0. So what method I have followed, this is called as chain rule. Okay, using chain rule I have written down this partial derivative. Fine. Now if I will make this equation little more simpler, so what I will do here, this equation even I can write in much more simpler fashion. That means I am writing down, so that means I am writing down del by del x of phi with respect to u, and then I am taking this term, this complete thing into right hand side. That means minus, because it is plus here, so minus del by del x of phi with respect to v. Okay, so these are just real, I did not do anything more. Similarly, for my second equation, what I am writing down, I am writing down del by del y of phi with respect to u. Okay, and then right hand side I will take this complete thing into the right hand side. That means minus del by del y of phi with respect to v. Fine, no? So this just I have rearranged these two things. I am just giving the name to equation number 2 and equation number 3. And my step number 1 is done. So my step number 1 is done, because my step number 1, I just have to find the partial derivative with respect to independent variables. Now I'm going to start my step number 2. So step number 2 is what? In my step number 2, whatever new equations I have got these two new equations. I just have to rearrange these two new equations, or somehow I have to manage with these two new equations, so that my final equation will be there that will not contain phi. Okay, why I don't want phi? Because phi is the arbitrary function, so I don't want phi. So I don't want phi because I have to eliminate the arbitrary function. But I don't have any problem with del by del x of u, or del by del y of u, or del by del x of v, or del by del y of v. Why I don't have problem with u and v? Because u, v are actually name given by me right now. This u, v is nothing but x plus y plus z, or x square plus y square minus z square. So x plus y plus z, or x square plus y square minus z square, these things are okay, correct, no? So they are not arbitrary. Fine. If you will focus on equation number 2 and equation number 3, if I will divide equation number 2 with equation number 3, then what will happen? So what I am writing down, these two equations, left hand side and right hand side, I am going to divide. Okay, so if I am dividing these two things, you will see that these two things are actually in the numerator also and the denominator also. That means del by del u of phi and del by del u of phi is in the numerator also and denominator also. Similarly, del by del v of phi and del by del v of phi is present in numerator also, denominator also. So I have cancelled out. So what are present? So what is there? Del by del x of u, okay, divided by del y of u equals minus also I will cancel. So it is nothing but del by del x of v divided by del y of v. And you will see that this is not containing phi. This is not containing arbitrary function. So this is actually my partial differential equation. Okay, but how this is my partial differential equation? So I will now replace u with x plus y plus z, and I will replace v with x square plus y square minus z square. And whatever I will get using this equation, that will be my final partial differential equation. So what I am writing down here? So till here we have done the same thing. Now My job is just to find del by del x of u, del by del x of v, del by del y of u and del by del y of v. Only these four things I have to find. And what is my u? I'm just writing down u and v here. So u is x plus y plus z, okay? And then v is x square plus y square minus z square. Okay, so what is my del by del x of u? This is nothing but del by del x of x plus y plus z. Right now, that means you can write del by del x of x plus del by del x of y plus del by del x of z. That means del by del x of x will give you 1. Del by del x of y will give you how much? 0. Why? Because I am finding out partial derivative with respect to x. So other variable will be treated as constant. So partial derivative of constant is nothing but 0 plus del by del x of z is p. Remember? So that means my del by del x of u is 1. So del by del x of u I have got. I have to find what is my del by del y of u. Okay. So del by del y of u is what? If I write down here del by del y of u. So I have to just rewrite it with y. Okay. So that means it will give you how much? This is nothing but if you'll see here, this is going to give me. So if you will see here, it is going to give me 0 because x is constant with respect to y, plus 1 plus del by del y of z is q. So del v, so this is what? So this is your del by del y of u, which is 1 plus q. So del by del y of u is 1 plus q. Fine. Similarly, we will be finding out del by del x of v. Correct? No, this is my v. So del by del x of v will give you how much? It is going to give you del by del x of v, that means 2 into x. Okay, so 2 into x, and then del by del x of y square will give you how much? Y square with respect to x will be constant, so it is going to give you 0 only. Now what is your del by del x of minus z square? That means I am just writing down del by del x of z square is nothing but 2 into z del by del x of z, that means 2 into z into p, 2 into z into p, and then minus is already there. Fine. Now I have to find del by del y of v. V is x square plus y square minus z square. Okay. So if I am finding out del by del y of v. So this is first term is going to be 0. Del by del y of x square is going to be 0. Now del by del y of y square and then minus, right? Now minus del by del y of z square. So this is 0 plus 2 into y, fine, minus del by del y of z square. It is going to be 2 into z into del by del y of z, that is nothing but q. So this is 2zq, minus is there, fine. That means we got all these four things, and just I have to write these four things here right now. So here we have written down whatever we have just now got, we have written down in that equation. 2 gets cancelled, and then we have done cross multiplication. So 1 plus p into y minus zq equals 1 plus q, fine, no, equals 1 plus q into x minus zp, and then we are just simplifying it, and finally which all terms are present with my p written down in one place, which all terms are there with my q written down in one place, and all those terms where p, q are not present we have written down here. Okay, so this is my required partial differential equation, because p, q, x, y, z all are allowed, and I am not finding phi, the arbitrary function here. So this is the answer. Okay, fine. Now we are going to see the second question. Exactly same manner, right? So this form 3 is, if it is coming in your exam, so you will find that your steps will be kind of exactly same. So this is what I'm again writing down. This is the form function here. Instead of phi, I'm writing down f. So this is f u comma v equals 0. Again, writing down uv is because this complete x square plus 2yz, y square plus 2zx, if in all the steps we will be writing down, it will be more confusing. So we have just replaced with the name uv, and later on we will be substituting with x square plus 2y and all. Fine, no? So my step number one is what? I have to So step number one is I have to partially differentiate with respect to x and partially differentiate with respect to y, because two independent variables are there and z is the function with respect to x and y. Okay now, and this f is only the arbitrary function. So in this given equation, left hand side and right hand side, both I am going to find partial derivative with respect to x first, then I will be finding out with respect to y also. Okay now, so what I am writing down, del by del x of function, okay, with respect to u, and then I will have to find del by del x of function with respect to v. Fine. So for that, what I'll be doing, and then right hand side will be your del by del x of 0. Fine. So that means what I am writing down here, this is nothing but del by del x of function with respect to u, okay, plus del by del x of function with respect to v. Fine. And this is nothing but 0. And here only what I am going to do, I am just writing down, rearranging this equation. Will here only rearrange the equation. Okay, I'll put this into the right hand side, so it will become my minus. Fine. Similarly, like how we had done in the previous question. Okay, now if I have to find the partial derivative of given equation with respect to y, so what I am going to write down? I am going to write down del by del y of function with respect to u, okay, and then plus del by del y of function with respect to v, okay. This is my left hand side, and right hand side is what? Del by del y of 0. So this is nothing but del by del y of 0, which will be 0 only. Fine, no? So here only what I am doing, I am rearranging the equation. So if I rearrange the equation, so this is 0 in the right hand side. So I will take into the right hand side and it will become minus. Fine, no? Okay. So this is my new equation, equation number 2. This is my new equation, equation number 3. So my step number 1 is done. Now my step number 2 is what? Whatever I have got two new equations, I just have to do some arrangement so that I will eliminate the arbitrary function. Okay, so same thing I am going to do. I am going to divide left hand side and right hand side. Okay, equation number 2 divided by equation number 3. So this del by del u of function and this del by del v of function from the right hand side, these two things are common. So I am going to cancel out, minus minus also gets cancelled. So same thing I have got here also. Okay, so you will find that this complete thing is same, right? So this is step, even this is step, equation number 2, equation number 3, and this division, everything is actually same in all your questions of your type 3. Okay, so it will be same in your form 3. What you just have to find, your work is to find del by del x of u, del by del y of u, del by del x of v, and then del by del y of v. And what is your u and what is your v? So we had said that u is x square plus 2yz. V is y square plus 2zx. So y square plus 2zx. Okay. So now I have to find del by del x of u. I'm going to find del by del x of u. So del by del x of u is what? Del by del x of x square plus del by del x of 2yz. That means 2 into x. Okay. Plus 2y is constant. Correct? No? With respect to x, 2 is constant and y is also constant. Correct? So it will be del by del x of z. So this is nothing but 2x plus 2y and then p. So 2x plus 2yp. Okay. Now we are finding out del by del x of v. Okay. So this one. So now I am finding out del by del x of v. So it is nothing but del by del x of y square. Okay. And then plus del by del x of z into x. So del by del x of y square will be 0 because y is constant with respect to x if I am finding out partial derivative. Plus this is what del by del x of z into u, that means product root. So z into del by del x of x plus this will be your x into del by del x of z. That means this right hand side is z and then this is 1. So z plus x into p. So z plus x into p is here. Okay, so somewhere some mistake is done. Okay, so this is your 2 into zx. So 2 is outside, correct? No, 2 into zx. So 2 I have written down outside. So now this is okay. Similarly, we will find del by del y of u, del by del y of v. So these four things if we have got, so we just have to put into this manner, correct? No, so these two values, so these four values we have just written down in this manner. So this is nothing but 2 gets cancelled and then we are doing this cross multiplication. Okay, so that means x plus yp into this will be your y plus x into q. Similarly, the right hand side will be how much? Yq plus z into z plus xp, because these two we have cancelled. And then we are just rearranging it. Fine, no, that means whatever terms are there with p we are taking aside, whatever terms are there with my q we are taking aside, and these terms are not having pq. So this is our required partial differential equation. Fine. So if you find this class useful, please like and subscribe my channel. Thank you.